Hello students, this is one of the important questions for pressure which you can solve for O-level physics. The question is about a rising molecule of gas. Water of depth 10 meter exerts a pressure equal to atmospheric pressure. An air bubble rises to the surface of the lake which is 20 meter deep, which means that the total depth of the lake is 20 meters. We have to understand this first. Now, when the bubble reaches the surface, its volume is 6 centimeter cube. What is the volume of the air bubble at the bottom of the lake? Now we know P1 V1 is equals to P2 V2. We have we don't have some things. We only have the volume at this volume at the end, which is 6 centimeter cube. We we know that the pressure at the surface will be 1 atm. We don't know we have to find V1, and the pressure is not yet to be found, but we can draw a diagram to help us understand what is really happening. Imagine this is the surface of the lake. This is the surface of the lake. What is the pressure here? At this point the pressure is 1 atm. The pressure at 10 meters is 1 atm, because the question itself states water of depth 10 meters exerts a pressure equal to atmospheric pressure. It means 1 atm. But the thing to understand that it is not only experiencing the total pressure 1 atm. 1 atm is due to the water, and 1 atm will be because of the atmosphere. It means the total is 1 plus 1 is equals to 2 atm. But due to the water is only 1 atm. Now what is the pressure at the bottom? We know the height is 20 meters, and what will be at the bottom? We know by the equation P is equals to H rho and G liquid. The pressure is directly proportional to height. If at 10 meters the pressure is 1 atm, what would be the pressure exerted by the liquid at 20 meters? If the length or height doubles, the pressure exerted by the liquid also doubles. Why? We can solve it through the ratio. If two quantities are directly proportional, we can say that P1 upon P2 is equals to H1 upon H2. And let me make you understand that the pressure taken here is due to liquid or water. Now let's solve it. If the pressure one is 1 atm and P2 is unknown, is equals to H1 is 10 upon 20. So P2 will be equal to what? 2 atm. Due to water at the bottom of the surface, it means here it is 2 atm, and it is not only 2 atm. We have to understand it. Why? Because it would be 2 plus 1, and hence 3 atm. Why? Now हमें क्या पता है? हमें पता है कि यहाँ पे 1 atm लग रहा है ड्यू टू द वाटर. यहाँ पे कितना लग रहा है हमें नहीं पता. यहाँ पे हमने क्या बोला? हमने बोला अगर 10 मीटर की हाइट पर 1 एटीएम लग रहा है तो 20 मीटर की हाइट के ऊपर डबल होना चाहिए, क्योंकि दोनों डायरेक्टली प्रोपोर्शनल है. हाइट डबल हो रही है तो प्रेशर भी डबल होना चाहिए. और ये कौन सा प्रेशर है? प्रेशर ड्यू टू द लिक्विड. अब अगर ये 1 एटीएम लग रहा था ड्यू टू द वाटर, तो यहाँ पे कितना लगना चाहिए? 2 एटीएम. लेकिन टोटल प्रेशर क्या लग रहा है बॉटम पे? 2 प्लस 1, क्योंकि एटमॉस्फेयर तो एटमॉस्फेयर का भी तो कोई प्रेशर होगा ना. एटमॉस्फेरिक प्रेशर इज इक्वल टू 1 एटीएम. 1 एटीएम को मल्टीप्लाई बाय 2 करा तो 2 एटीएम हो गया, जो मैंने पूरा को सॉल्व करके समझाया कि हमने डायरेक्ट रेशियो से इस तरह सॉल्व किया. आफ्टर फाइंडिंग आउट वी विल ऐड 1 ड्यू टू द एटमॉस्फेरिक प्रेशर that is being applied at any level of the water. Now we know that P1 is equals to 3 atm. V1 is unknown, while we know that P2 is 1 atm. How it is 1 atm? क्योंकि एट द सरफेस तो 1 atm था ना, सरफेस तो पे तो 1 atm है, और सरफेस के ऊपर वॉल्यूम क्या है सवाल में दिया हुआ है, v2 क्या है, v2 है 6 centimeter cube. Now if we solve this question in here, so p1 is 3 multiplied by v1 is equals to p2 is 1 atm multiplied by v2 is 6 centimeter cube. 6 centimeter cube. So v1 is equals to 3 1 is 3, 3 2 is 6, it is equals to 3, it equals to 2 centimeter cube. Hence the answer will be A. Now the students will be get confused if they use the wrong thing. If they do not add 1 here, the answer would be 3, and thus it is wrong because we have to always add the pressure that is being applied by the atmosphere. This is one of the most like comprehensive questions in which all of the elements for the liquid pressure are tested by the examiner, because you have to be always alert that the atmospheric pressure is always being applied, and the total pressure is the sum of the atmospheric pressure and the pressure applied by the liquid. And in this scenario the liquid was water, and we used the the pressure at the depth of 10 meters to find the pressure at the depth of 20 meters, and the pressure that we found was only due to the water, and hence to find the total pressure at the bottom we must add the pressure applied by the atmosphere. Okay, so students, we must always be cautious while solving these types of questions, because examiner always in the MCQs wants to get your answer wrong by making you miss some small details that you may always know, but if you forgot in applying in the exam, then your marks are gone. So thank you.